Welcome back, guys. My name is Dr. AVITECH, and in this video, we're going to be solving this very problem. So we're going to be integrating from 0 to infinity x to the power of 6 e to the power of negative 4x squared dx. That's an easy one. The only problem is the exponential should not have a minus 4x squared. It should just have a single x. It should just have a single x. It should just be raised to a single variable, a negative single variable. So the minus is always there. So the x is our problem. It should just be x and not 4x squared. So let us call it something else. Let us say that u should equal, I don't know why I like using u. You can use any alphabet of your choice. So u is equal to 4x squared. Now if u is equal to 4x squared, let us make x the subject. First of all, you have to divide by 4. You have to divide by 4. So this is u over 4 equal to s squared. And what is the next thing you're going to do? The next thing you're going to do is to take the half of both sides. You know, if this is square, you have to take the square root of both sides. But remember, I do not like writing square roots. I just like writing the power of half, because square roots and the power of half mean the same thing. So this is u over 4 all to the power of half equal to x. Yeah. But remember that 4 has a square root, right? 4 has a square root. So this actually is u to the power of half. Only the u will then have the half. And then for 4 to the power of half, which is the square root of 4, is 2. And then this will equal to x. So you've been able to, make x the subject. Now the next thing I want to do is to find the x. Find the x, dx. So u is equal to 4x squared. So what I'm going to do is to say that du is equal 8x dx. Yeah, du is equal 4 times 2 is 8, and then you put your x, 2 minus 1, that's 1. Now, but the main thing is we're trying to make ds subject. So to make ds subject, we're going to divide both sides by 8x. So this is du divided by 8x equal to dx. Now, since we're trying to remove every single x term, on this side, this is du. This should also have u. The x should also be u. So right now, remember that we've made s the subject, and s is actually u half over 2. So this should be du divided by 8 times u to the power of half over 2. So 2 here is 1, 2 here is 4. So this is equal to dx. Okay, so this becomes du divided by 4u to the power of half dx. Okay, equal to, I do not like using my hand for the red color, equal to dx. Okay, now at this point, we've been able to find everything that we need. So this guy has been gotten. That guy is very important. This is very important. This is very important. So let's use all of these guys to get our answers. So this will be the integral from 0 to infinity. Oh, that's it, not infinity. To infinity of x. What is x? X is u to the power of half over 2. So this is u to the power of half over 2. But it's raised to the power of 6. So every single thing here is raised to the power of 6. And then this is e to minus, what is 4s squared? 4s squared is equal to u. And then what is dx? Dx is du divided by 4u half. So this is du divided by 4u to the power of half. Okay. So this will equal to integral from 0 to infinity of, let's expand this. This will be u. Now, half times 6 is just 3. So that's u cubed. That's just u cubed. And then we have 2 to the power of 6. 2 to the power of 6. And this is e to negative u du divided by 4u to the power of half. Okay. Let's see. Now, 2 to the power of 6 is 64. So this will become integral from 0 to infinity u cubed divided by 64 e to negative u. Hold on. Remember to hit the subscribe button and like this video. And then this will be du divided by 4u to the power of half. Now, notice how 64 and 4, they are the denominator. So it means I can actually bring them out. 64 times 4 is 256. So I want to bring that out. So this will become 1 over 256, integral from 0 to infinity. Then what's going to be left is just the numerator. So that's u to the power of 3 e to negative u du. We still have this guy here, u to the power of half. U to the power of half is still there. Okay, now we could say, since this is u to the power of 3 divided by u to the power of half, if you have two guys that are dividing, you're going to subtract the powers. You're going to be subtracting the powers. Remember that this over is actually supposed to be like this. So it's still the same. It's still the same. So this u, are going to subtract them. So this is 1 divided by 256, integral from 0 to infinity, u to the power of 3 minus half, e to negative u du. Okay, that's looking fine, actually. It's looking fine. So this is equal 1 over 256. Okay, I still have integral from 0 to infinity of u. What is 3 minus half? That's 5 over 2. Yeah, 3 minus half. Okay, so this is over 1. LCM is 2. 2 divided by 1, that's 2 times 3, 6. 2 over 2 is 1. 1 times 1 is 1. So that's 5 over 2. So this is u to the power of 5 over 2, e to negative u du. Okay, now, can we say 5 over 2 factorial? No. So we're going to be writing it in terms of what? Gamma. We're going to write it in terms of gamma, because we cannot write that in terms of factorial. Remember to watch the playlist of this very video. It is much more convenient that these videos are watched with full screen. Yeah, and you can always change the quality to the highest definition. So this is 1 over 256 times the gamma of this 5 over 2, right? When you're moving from here, this is x. So the x in this case is 5 over 2. So from this point back to this point, you're going to say x plus 1. So that's 5 over 2 plus 1. In terms of factorial, when you want to do that. So this is 1 over 256 times the gamma of 7 over 2. Yeah, 5 over 2 plus 1 is 7 over 2. So you just have to go through this. So let me not do that again. So this is 1 over 256 times. Now this is the beautiful thing about this. Basically, remember that in the first video, I showed you how to use the recurrence relation to solve for something like this. Because the gamma of 1 over 2 is the square root of pi. I believe that's easy to know. So you can always solve every single thing that deals with half integers. Anything that's over 2 can actually be solved. So what we're going to say here is the gamma of 7 over 2. What are we going to say? This will become 5 over 2 times 5 over 2 minus 1. That's 3 over 2. 3 over 2 minus 1. That's 1 over 2. When you get to 1 over 2, this will be 1 over 2 gamma 1 over 2. You need to go watch that first video. I actually explained this step by step. Because if this is the gamma of 7 over 2, you will need to start reducing this by 1 continuously until you get towards half. So 7 over 2 minus 1, that's 5 over 2, which was 5 over 2 here, times 5 over 2 minus 1 is 3 over 2, 3 over 2 minus 1 is 1 over 2, and then gamma 1 over 2. Because if you say 1 over 2 minus 1 again, that's going to be minus half. You do not want to do that. Okay, so let's see. This is 1 divided by 256 times 5 times 3 is 15. So this is 15 divided by 222, that's 8. And then the gamma of half is the square root of pi. Okay, now this times this, that's going to be like a nice number. Well, let me see. This is 8. This is 8. This is what's it called? This is 3. So that's 11. So that's 2048. So that's 15 divided by 2048 root pi. Yeah, and that's going to be the answer to that very problem. Yeah, it's a fine one. Yeah, basically it is. So this is what the answer to this very problem is going to be. And this will be all for this very question. Remember to hit the subscribe button, like this very video, and share it across to your classmates. I'll see you in the next one.